going to invite Robert Malczyk, the principal at Timber Engineering, to come on stage here. Robert's got 25 years in design and construction industry. He's got tons of expertise in timber engineering. We actually worked together on the AGO project years ago, which was one of the big mass timber projects in the early 2000s in Toronto. He's worked on over 600 projects and won several awards around the world. He's going to be talking about virtual construction and how we actually make things work in real life. So excited to hear about this application and all of your experience. So thank you, Robert.
Thank you, Thomas. It's really a pleasure to be presenting my little project here. First of all, I just want to congratulate Lucas. We actually were the second ones on the Taiwan project, and it's a wonderfully executed one. So Lucas and team at Structure have congratulations. My project is a tiny one. This is what happens when the structural engineer decides to be a developer of our own office building. This will be the headquarters of our timber engineering here in Vancouver. And Timber Engineering is a firm that we just formed this year after our 4-year adventures with Katera. The project is downtown in Vancouver, just outside of Olympic Village at 5th and Ontario, and that's why we call it On 5. And it's a 5-story office building, what's challenging here, it's a lot. The lot is 25 foot wide and 130 feet long. And the access is only from the street because of the hydro lines on the other side. It's a light industrial on the first couple floors, and they had to be non-combustible, and then fully prefabricated mass timber in passive house format on top of that. Pretty much the main message of my talk is that on this project, we try to do as much use of BIM and virtual construction as possible with the constraints of the current project process in the city of Vancouver. The reality of approval process is 1.5 years of development permit, over a year of building permit, and you have to submit standard consultant drawings in 2D regular submission for a building permit. So when you start considering doing CAD, you kind of feel like an animal being tested. You talk to developers and your friends are saying, oh, this paying for extra modeling and BIM, it's useless because there will be problems on site anyway, and always it is being fixed the way it always was by cutting, recutting, and adjusting. So then you talk about to the contractors, and the contractors, they now have the capacity to do the BIM models. You also talk to your architect friends and to other friends, and pretty much you're very much confused of who is supposed to be doing this model. There is really no standard process of how to do it. My personal opinion is that the contractor is probably the best to do this final model, and that's what we did here. So Naikun Construction was selected to coordinate this BIM model, but there were several BIM models, like on a typical project. So architectural design, John Hemsworth was the architect, wonderful design. We've done a lot of great buildings with John. They started working on SketchUp, and this was a great software just to figure out, for example, our scissor stairs and the geometry. And then structural design, we started working at CadWork. At that time, I was still a principal at Equilibrium. So CadWork was the model, and then finally, of course, the CadWork model was used for shop drawings. MEPF design, 2D AutoCAD, I'm not aware of any 3D during that. For contractor pricing, this was the first initial Revitt model. They did it for volumes, for calculations, for construction planning. And then there was a final, pretty much shop drawing quality model out of BIM that was prepared by Naikun. We entered our CadWork model into it as Katera CLT was provided for that. So during the erection planning, we had multiple workshops, and that was kind of the biggest use of this Revitt thing. What we learned is that what helped us hugely was that we wanted to do a passive house building with 100% wall prefabrication. On all my previous CLT projects and mass timber projects, we were lifting up CLT, and then there was insulation, and then finishes and everything else. And here with Naikun, we did an experiment. We actually were working together with them. And on the left, you see the final panels. Here you see how we were applying the first layers on the CLT in outside positions. It was a very experimental and low budget project. Here we're going back into the spacers, and then the insulation, 8 inches of insulation was used on top of it. It's a passive house building. And then, of course, we have the final finish. After we applied the final finish, we actually did the testing. We were lifting the panels. We were afraid of buckling of the steel on the outside. So that's here you see our facility to do the prefabrication. And as you've seen on the previous pictures, the building is against the 2 other buildings. So we pretty much had no choice. We had to 100% prefabricate. The virtual construction was a big part of it because of the tightness of the site and because of the complication of the geometry. So the process that you see right now, we actually did, I would say probably around 8-9 times, where we were sitting together with the crane guys, with the installers, with everybody else, and day by day planning our erection. Of course, it's crucial for the cost of the project because the crane to lift 150 feet over to the other side of the building in $750 an hour. So every hour you can shave off of this. It's a big savings for ultimately for me, the owner of the building. So here you see how we're going into the center of the building. We had several innovations in this building other than prefabrication. We used the whole self-centering hold downs, which I'll be showing in a minute. But we also use the flat slabs, the TS3 system, because 25 foot is too much to span the CLT in a single span, and we used 5-ply. So we actually used a 2-way span CLT with we glued it with first primer installed in a CLT plant, and then after that on site. So here you see we keep on going through the process of installation. So I will just speed it up. The issue with the approvals was a big thing. The walls, typically for buildings like that, are used in masonry, as you see in the adjacent building. Here we wanted to do 5-ply CLT that supports the vertical loads, that supports the shear walls, and also is insulated to passive house standard. So it took some time to convince the city to satisfy all the requirements for the fire testing and for the structural behavior, of course, calculation of charring and all of that. We found that talking to the city, we first tried to get a lot of buy-in with the guys on top, and what we found that there was still a lot of education that we had to provide during the process of approvals. One of the biggest benefits of having such a great Revitt file was that every day we actually designed every single piece, every single person on up there, what they were doing, and pretty much with 15-minute increments, kind of like lawyers. And in the end, we were able to achieve just that. So the process of huge amount of preparation upfront actually paid off. For myself as a structural engineer, we actually had to design for the windstorm every single day after the site was left. And, you know, on top of that, it was also my financial interest in the building. So with this, we were able to pretty much perform our structural analysis at every stage for temporary bracing and for high wind loads that actually never came, but we were ready for them all the time. When you deal with passive house and you deal with the tightness, it requires an incredible accuracy. And as we all know, CLT comes very exact. But the concrete, as much as you want it to be to the same 2-3 millimeters as CLT, it never is. So here you see an example how we were leveling off and actually putting these outside prefabricated panels on washers to make sure that they're absolutely level and everything fits beautifully well. Here you see how the panels started to be dropped on site. And again, behind, you see the hydro lines, how close we had to go to the hydro lines, how careful we had to be with the installation. And here you see the long reach of the crane from the street. And all the connections on the inside, the shear connections, all the envelope connections were done on the inside of the building. Just the little covers for pretty much for the looks were installed afterwards on that. So here we go, day by day. We planned for 14 days. We delivered in 14 days, and that was a big achievement. We used a whole variety of instruments. Here you see the little lift that was very handy on the inside. Now, as we were going towards the center of the building, especially to the shear walls, because here you see the elevator shaft is pretty much holding the whole building. And here you see the lift and myself, you know, as the owner sitting on the other side. And it took like 4 hours to install this first very long panel, which is over 40 feet and 10 foot wide. And here you see the temporary support of that. And what was incredibly handy was that Nikon had this device that was able to release the panels without somebody going to the top of the panel, which is incredibly hard on a zero load environment like that. So that was a wonderful thing to be able to release it automatically. So CLT shear wall hold down fit was probably the biggest challenge. And here you see the same shear wall being dropped down. And the way it works, you have the shoes that take the shear of the wall, and then the Tectonus self-centering hold down devices. What the self-centering is that the building will move during an earthquake, and after that it will center itself to the vertical position. So what is required here is actually incredible accuracy. Here you see the hold downs going all the way down into the concrete, and then the connection above is also designed. This is all capacity designed. So the connection in orange is a fuse. This is where you want to dissipate your energy. So imagine the accuracy. You're holding this huge panel, and you have to fit these steel-to-steel bolts into the threaded 1.5 inch plate top and bottom. So this is why we actually took out the concrete below here to have a little bit of an adjustment on both directions and also up and down. And everything did fit beautifully. These hold-down anchors, they're actually a fantastic invention. Pierre Canville, Tectonus out of Auckland, New Zealand, they squish these washers, they squish themselves, and they dissipate this energy, and also the orange part goes up and down during an earthquake. So here you see Ryan doing our site super doing the final check that everything actually fits beautifully for this self-centering device. The other thing, that there are different types of the self-centering device. There are the ones where you have the rods, and the Buchanan, also from New Zealand, developed these. We use them at Equilibrium at Oregon State University. This one here, there was so little space in this building that we wanted to have it flush within the face of the wall, not to lose space in the building. So that's why Tectonus was the best way to do it. This is the last panel of the elevator shaft being on top. This was already much easier. By the way, the second one with Tectonus, the second panel with Tectonus already took half of the time as the first one. That was a huge relief. So then we keep going. Everything else was also prefabricated. Secondary walls shown here in brown, and also the stairs. Everything was flying in as part of the prefabricated process. Here you see around the staircases complicated cuts in CLT. And again, I was just reading out, watching it every day, that everything did fit beautifully. You also see how we were using these angles that CLT is sitting on. This building has no columns and no beams. It's pretty much a box. Everything sits on the CLT. And here you see we were using them also as a temporary support and temporary location for these panels. So we keep on going with our process, and during the virtual process, we're actually lifting all of these things using Revitt. So here you see one of the last panels being lifted on site, and we had to close the street for the time of the construction. So of course, this is another process of approvals, and here you see how the panel is going nicely down and is sitting on these angles that are then pre-approved on top. And all the other part of prefabrication, the other stairs and the walls are flying in at the same time. Here you see the facade already, the three-story facade that fully prefabricated is already installed like that. We got lucky with the weather. We were installing in August, and there was only one weekend of rain. And because the top panels already came with the membrane, the wet damage was minimal. This is always an issue with CLT, and here it also is an issue with the fit, because as we know, wood is a living material, and every change in moisture, every change in wetness changes the geometry of the panel, which is as you've seen, for example, for the shear wall element, had to be 100% exact. So here you see how the project looks like from the other side of the street, and maybe with this video we can look at for the future what else could have we done, or what else we could do on it. Definitely doing more prefabrication with finishes for the roof panels. would be the next step. Here, the insulation will be done after for the roof elements. The issue, of course, is how do you figure out the connection in between? Another issue is the approvals of other consultants, your code consultant, your envelope consultant. They have to go to the prefab plant. They have to do some of the inspections over there, which is also a little bit of a different process. So you have to kind of advise them that this will be all prefabricated. Here you see how skinny the project is and how we had to go all the way across. This is a wonderful crew from Nikon that installed it with Ryan, the tallest guy, running the whole show. They absolutely did a fantastic job. And the great thing is that we were doing it many times before with exactly the same people, with the guys running the crane, and I think only because of that, only because of these multiple virtual erection processes, everything went in so smoothly. So another thing, for the future, what I think would be worth trying is to have early exact model. So have the model that is actually to the quality of shop drawings right up front. It is hard because engineers and architects and MEPF consultants, we are not used to working like that. We are used to creating packages for building permit. We are used to doing our designs in 2D. And only now we're starting to do 3D, but everything that is needed for the approval still follows the old process. So early exact model would be absolutely wonderful. And this one here, that the prefabrication of everything else. So here you see the stairs. We will definitely try on the next project to do a prefabrication of stair with finishes, so everything can be just plugged in. There is, of course, way more with mechanical, electrical, and everything else. At the same time, as a developer, I have to deal with the reality of who can actually build my project, who is available in the market, when these people are available, and the whole process of approvals. So, as I said, we try to do as much as possible on this little job in Vancouver, but there is still a lot more to go to achieve the 100% prefabrication that can be fully modeled. Thank you. Any questions on our little building?
Really, really great presentation. I really enjoyed the practicality of it, and your insight as both the owner and the builder and the designer. It's pretty rare you get that combination and that perspective. So when you set about to start this project, obviously the first at the early stages you have to figure out your engineering details and whatnot around the envelope. Are there special considerations regarding using CLT? Considering speccing envelope?
Yeah, there is this attitude among a lot of CLT producers to avoid prefabrication. And, the first talk that you were just presenting, this conference element 5, I really welcome that they are the ones that are doing that. I'm talking to Structural, and they're also willing to start doing that. Few of the other fabricators, they pretty much said we are in the business of selling CLT and delivering CLT. It's an issue of liability. It's an issue of what if something gets wrong? Who takes the responsibility for that? And I think as an industry, we need to start addressing that, because this is something that it's kind of blocking the implication, the use of prefabrication. We need to sort out this liability. Maybe envelope consultants going to the plant, working together. Maybe something in the code needs to be changed. So CLT is absolutely perfect for prefabrication, but we need to kind of overwhelm this. We need to overcome this this current state where CLT just comes in and then gets wet and then gets covered. So that's the challenge.
There's a question that came in here regarding, considering the adjacent buildings. So, how do you consider the impact of the adjacent buildings, and would you have to consider that during like a seismic event? Are there special considerations regarding height, stiffness, lateral movements that could cause problems for a mass timber project?
So I don't see any difference, between mass timber project and a steel moment frame or a concrete shear wall. We calculate our deflections, we do our pushover analysis, we make sure that we are within the limit of the gap between the buildings, so we don't have the pounding of the buildings. Here, it was a very long building, so we had to make sure that the diaphragm actually doesn't deflect horizontally too much. That's why we installed 2 little moment frames to limit the deflection of the diaphragm at the front and at the back of the building. But from generally from the CLT shear walls, absolutely no problem. They're actually wonderful for us engineers because of a much lower weight, the 1/6 the weight of concrete. And we have the self-centering devices or a post-tensioning available to dissipate energy to get the buildings for this immediate occupancy. And that's what us owners want. We want to be able to use the building immediately after seismic event without replacement of any parts.
So just another point of consideration. I think you mentioned during erection that you have to consider moisture and exposure to weather. Did you delay or schedule your erection sequence based on weather conditions, or were you prepared for any condition? Like, what are the special considerations there? Do you need more temporary things to kind of protect the wood? Maybe you can elaborate on that a little bit.
Yeah, so we try to be ready for everything. We're in Vancouver, we're in a wet climate, so we try to be ready for anything. But of course, with the whole process of construction, we try to do it in the dry months of July, August, September. And we achieved that. We achieved that with a very long process of planning of everything else, demolishing of existing building, digging out, underpinning, foundation work, and everything else was actually done on time and on budget. So it's everybody tries the same thing in Vancouver: May, June, July, August, September. These are the months. But sometimes it doesn't work. We've done several projects here in Lower Mainland where we were building November, December, January, February, when it just rains for a month. And then covering the CLT with the membrane works, then doing as much covering of the insulation works. In our case, we installed this black Siga tape to enclose the insulation. So insulation never got wet. And even when it was exposed as a part of the front and the back of the building to the rains that always come in our climate.
Do you foresee, in the Vancouver market especially, do you foresee bottlenecks with availability of erection crews that can manage CLT? Because obviously everyone's going to be trying to schedule their work so it all happens in July and August. That's, I guess, one of the constraints with working with timber.
I'm aware of quite few of the great erection and qualified erection process companies here in Vancouver, in BC general. We are the cluster of excellence in mass timber. At least that's what we would like to believe. As much as you guys are center of the world in Toronto, we think we are more of a cluster of mass timber. Excellent companies on the fabrication, design, architects, engineers, other consultants. So I don't see this as an issue. I think we have good capacity to deliver. And actually, around my building here, there are like 5 or 6 projects already built in CLT. and there are 2 or 3 already big ones planned within 2 blocks. So it is becoming very popular in these narrow sites, narrow downtown sites.
When you're the owner on this project, you would have been responsible for the capital required to build the project. And as much as the project was erected and assembled in 14 days, which is amazing, did you have to carry the capital cost of fabrication and storage during that period, or were you able to manage your purchasing and storage to minimize that, so it was sort of just in time, so that your carrying cost was as short as possible?
You actually need to pay in advance. This is one of the drawbacks. You pay for all the BIM and the preparation and all the work by the contractor and the design team in advance. You pay for CLT in advance to have it prefabricated. We actually purchased a CLT last year, and we had it since January. And there was a long process of prefabrication. You probably can do it faster on the next project. At the same time, I knew that there was a large demand coming for the CLT this summer, so I wanted to make sure that I have it way before I actually needed it. But that's a very good point, that if you do prefabrication, you have to pay faster.
Yeah, I mean, you have a lot more upfront costs, but you're minimizing your downstream risk. But just given the demand for the product in the market right now, which I think is grown like 5-fold in the past couple of years, and the shortage of supply, you have this sort of bottleneck where you have to place your orders in advance and kind of schedule your whole project around the availability of the factory to produce the materials, and of course try to minimize that window of storage so you can get to opening up the doors on the building as fast as possible. So definitely
that's right. But if I could give an advice to other people considering, do as much prefab as possible. We're watching another project in the area that insulation had to be replaced, and it took 5 months of lifting and fixing the cladding, because it's just so hard when it's up and it's wet and it's dry and it's in the weather. It's in the end, it is cheaper to prefab walls like the ones that I showed.
So there's a question that just came in from Andrew. If and when the wood prices fall again, what are the implications on the massive amount of documentation that will follow? Curious on your perspective on just the wood prices in general. I mean, I've read that they're coming down, but I'm not sure they actually are.
I think they are already around 500. So from the peaks of almost 3 times that. So as far as I know, that was a very short peak, and the average prices were stable for many years before, and I'm hoping that they will be like that in the future.
Yeah, so I mean, I think we've kind of covered most of the considerations. If people want to get a hold of you, Robert, to learn more about your offerings, your company, what would be the best way to do that?
I think just to check us out, Timber Engineering, and that's where we are now. We'll be launching our website very soon, and in Vancouver, it's such a small market that we kind of all know each other, so it's easy to find a person that knows us, and because we are already involved in several similar projects, it seems to be the interest among developers. We had a couple days of tours, over 30 developers on the first one, then around 17 on the second one. Great help from NRCan on this project, FII on this project, and promotion of this CLT. A lot of developers are telling us that this project showed that you can do a skinny side in CLT in a tight urban environment. In an economical way. So that's a success in my mind.
Excellent. Just one last question before we wrap up here from Tracy. What would you change about your approach to working with AHJs about alignment and building codes and variances?
I think I would allow more of submission of the 3D models and go away from the traditional process of 2D drawings and go more into the submission of the BIM models for permit. I know that this will require a different type of people at city halls and different skills of these people, but I think it will raise the level of the quality of the construction, and it will give architects and engineers an incentive to start doing everything to the shop drawing quality right up front. So we don't have to redo and redo and redo in the different software packages.
Right on. Well, thank you so much. Excellent work from out of Vancouver, BC, Canada. So wonderful, and we'll have you back hopefully soon.
Thank you.
Thanks.